Thank you, ma'am. Here we go. We are still doing climatology, and here we are going to, earlier what we had checked out was we had said we look at the three indicators of the weather, which is temperature, humidity, and pressure, okay, and related phenomenon and stuff like that. अरे दो दो करके बैठ जाइए, ऐसे क्या, इतनी सारी स्पेस तो है क्लास में पूरे. Here we are. But he, कोई problem नहीं. It just didn't fit well in my thing head, so I thought I'll tell you this. No problem. Here we are. We are looking at temperature first, then pressure, then humidity and pressure. We already looked through temperature. हमने देखा कि temperature जो होता है, हमने देखा कि टेम्परेचर जो है उसके लिए वी स्टडीड आइसोथर्म्स. रिमेंबर वी बीन थ्रू दिस. वी स्टडीड द आइसोथर्म्स, वी स्टडीड द वेरियस फैक्टर्स that affected the distribution of temperature and everything, including latitude, altitude, continentality. Remember we had seen that distance from the sea, and then air masses या ocean currents वगैरह जब आते हैं तब. ओके, टेम्परेचर इन्वर्जन स्टडी किया था, उसके डिफरेंट डिफरेंट टाइप स्टडी किए थे, उसके स्पेशल कंडीशंस प्लीज याद रखिए, उसका सिग्निफिकेंस याद रखिए. आपको यूजुअली ये नहीं पूछेंगे कि स्टैटिक, nobody who doesn't understand Hindi here, right? ऐसा कोई नहीं है जिसको हिंदी नहीं समझ आ रही है ना, सबको समझ आती है. गुड, ओके. सो नेसेसरली ये नहीं पूछते आपको कि स्टैटिक टेम्परेचर इन्वर्जन क्या होता है या फिर रेडिएशन फॉग क्या होता है और समथिंग लाइक दैट. फॉर एग्जांपल ये जो स्टैटिक सरफेस टेम्परेचर इन्वर्जन है उसको रेडिएशन फॉग भी बुलाते हैं. ओके, सो यू आर नॉट नेवर, यू यूजुअली डोंट, यू ऐसे नहीं पूछते आपको कि इसमें से रेडिएशन फॉग क्या है, बट आपको ये जरूर पूछते हैं कि इसमें से कौन से कंडीशंस टेम्परेचर इन्वर्जन के लिए सूटेबल है, एंड दिस यू शुड डेफिनेटली नो. ओके, ये सब आपको पता होना चाहिए. ठीक है. एंड फॉर्म्स फर्स्ट एंड एटमॉस्फेरिक स्टेबिलिटी इज द सिग्निफिकेंस और इट इज फॉर्म ड्यू टू टेम्परेचर इन्वर्जन. ओके, नाउ यू गो ऑन टू ह्यूमिडिटी एंड प्रेसिपिटेशन. हाँ, अभी हम देखते हैं कि ह्यूमिडिटी एंड precipitation माने रेनफॉल, कंडेंसेशन वगैरह. वी लुक एट ऑल दोस थिंग्स. ओके, so first of all, we'll try to understand what humidity is. What is humidity? It is the water vapor content in the air. कोई भी हवा में जो water, okay, whatever water vapor content is held in the air is termed as humidity. Okay, now can that vary from place to place? Yes, it can vary from place to place. Okay, if you're near the coastal regions, obviously the humidity will be a little higher. Okay, if you are somewhere in the deserts, obviously aridity, because there is such a lot of aridity, obviously the humidity levels will be a little lower. Okay, clear? ठीक है. तो it will clearly depend on multiple factors. One, the availability of water vapor, temperature पे depend करेगा, sometimes little on pressure and so on and so forth. Okay, so we are saying the humidity is going to vary a little. Okay, now next you try to understand the three different types of humidities. Okay, we'll call them absolute humidity, specific humidity, and relative humidity. All right. Absolute humidity को समझते हैं. Let's try to understand absolute humidity. You say absolute humidity is the moisture content per volume of air. Okay. See what we are comparing it against. We are saying we are looking at the mass of water vapor in a volume of air. Okay, in a unit volume of air. Okay, mass of water vapor in a unit volume of air. So at a definite temperature. Okay, obviously that also is going to be एक guys यार बातें ना कीजिए आपके साथ, कैसे छोटे साथ बातें करना शुरू करते हैं यार आप. इट इज द मॉइस्चर कंटेंट जो भी होगा एक वॉल्यूम में देख रहे हो. ओके, उसको कंपेयर कर रहे हैं एक वॉल्यूम से. ठीक है. नाउ इट इज द एक्चुअल अमाउंट ऑफ वाटर वेपर प्रेजेंट इन द एटमॉस्फेयर एंड it is the actual amount of water vapor present in the atmosphere, and it's measured in gram per meter cube. Okay, gram for the mass and meter cube for the volume. So you clearly know this is a mass to volume ratio. Okay, this is going to be a mass to volume ratio. Now this will differ from place to place. It decreases from equator to poles because at the equator there is actually water vapor available, right? Because of the heat, there is actually water vapor available. The poles are extremely cold. What kind of water vapor can you expect over there, right? Obviously the humidity levels are going to be a little lower, right? And it is dependent on temperature. The reason being कि this is a this is a comparison between the mass of water vapor in a unit volume of air. Okay. Now this is not a comparison from mass to mass. If it were a comparison from mass to mass, temperature wouldn't have made a difference. Okay. But this is a comparison from mass to mass and volume. So that volume is changeable, right? Now with temperature, the volume can clearly change, right? Agreed? With high temperature, the volume can change. response, clearly the volume also changes. Now, if the volume changes, then the value of your absolute humidity also changes. So it is slightly dependent on temperature. Okay, it is slightly a little dependent on temperature, and this whatever precipitation is derived. What is precipitation ultimately? You see, you take water vapor from the air, take it upwards, condense it into clouds, condense it into water droplets, and those are clouds. And then when that rains down, you call that as precipitation. So where is the original water vapor coming from? From the atmosphere itself. Okay. So if you are deciding on how much precipitation a place is going to receive, it will depend largely upon what kind of absolute humidity the place has. How much water vapor is essentially available will ultimately decide how much precipitation is going to rain down upon you. Okay. Okay. Fine. Clear? The next thing that you look at is specific humidity. Okay, the second type of humidity you consider is specific humidity. Okay, now that is a comparison between mass and mass. It says the mass of water vapor present in a unit mass of moisture. You see, there is a difference between absolute and specific humidity. Absolute humidity was trying to measure the mass of water vapor in a unit volume of air, okay, at a definite temperature. What is this doing? It is comparing mass to mass of water vapor in mass of unit air. Okay, that is what you're measuring. So this is expressed as gram per kg, and this is called as a geographer's yardstick. The reason why it is called as a geographer's yardstick is because it is definite. It does not change. It is not subject to change by changes in temperature and pressure. Okay. If the temperature changes, will mass be affected? No, mass is the actual amount of water vapor, right? It won't be affected by temperature, right? Agreed? So clearly, specific humidity in most cases tries to remain as constant as possible, and hence it is the easiest way for measurement. Okay, hence it is called as the geographer's yardstick. Okay, a very simple question could be, out of all these humidities, which humidity is called as the geographer's yardstick? And it's going to be specific humidity. Okay, which is not dependent on temperature. Specific humidity is not dependent on temperature. Absolute humidity has to depend a little on temperature. Okay, okay. And we are saying specific humidity is the measure of quantity of water that can be extracted from atmosphere. Same, no? You are discussing how much water can be extracted from the atmosphere that will finally come down as precipitation. That is essentially what you're looking at. So both absolute and specific humidity will aim towards the same thing. But the specific humidity is a far more constant quantity for geographers or people who are measuring and taking all those things. For measurements, it is a far more absolute standard. Okay, it is a better standard for that. Hence called as the geographer's yardstick. Okay. Now you come to the most important humidity of all, which is called as the relative humidity. Okay, relative meaning clearly you're making comparisons now. Okay, maroon shirt and purple shirt. Do you wish to contribute something else to the classroom? Silence speaks volumes. No problem. Relative humidity. We are saying it is the ratio of actual amount of water vapor in the air to the maximum amount of water vapor that can be held at that temperature. Okay. Now let's try to understand both terms. We are saying there is an actual amount of water vapor. Okay. As opposed to you're considering or comparing it with the amount of water vapor that can be held. Okay. So for example, if 100 drops of water vapor can be held, okay, and only 60 drops of water vapor are here. Okay. So what is the relative humidity? 60 upon 100, so 60%. Okay. It will be expressed as a percentage. So we are saying it is going to be 60%. Okay. So absolute relative humidity is going to be the actual amount of water vapor, the ratio of actual amount of water vapor in the air to the maximum amount that can be held. Okay. How much water vapor can be contained to saturate that entire amount, okay, that of water vapor. There is a specific capacity, at a certain temperature, so much amount of water vapor can be held, okay. So that we call as the humidity capacity, okay. This, the lower term, the denominator is what we call as the humidity capacity, okay. Okay. And the actual amount of water vapor held in air is called as absolute humidity, okay. So relative humidity is absolute humidity divided by humidity capacity into 100. Okay, and since both are humidities, the ratio is an actual percentage. Okay, it will absolutely be an percentage. Is this good? Okay, so you are trying to see how much water vapor is being held in the air as opposed to how much it can contain to the maximum limit. Okay, that is what we are checking out. Now this is expressed as a percentage, and saturation occurs when the relative humidity becomes 100%. Okay, now tell me, if the saturation has to occur, either the humidity capacity has to decrease or the absolute humidity has to increase. Right? That is the one thing in which 100% can be reached, right? What is saturation? That the figure, that the amount or the value becomes 100, right? 100% will be saturation. So you are essentially saying that the numerator has to increase or the denominator has to decrease. Only in that case can the value increase, right? Final value increase. So absolute, are there any ways to increase absolute humidity at a specific temperature? No. right? There are no ways to, can you add more water vapor in any way? No. The only way to control this is to decrease the humidity capacity. And how do you decrease the humidity capacity? If the temperature falls, okay? If the temperature falls, how much water vapor can it hold? Can dry air hold, can cold air hold more water vapor, or can hot air hold more water vapor? Hot air, right? When the temperature is higher, clearly the capacity to hold water vapor is increased, right? When the temperature keeps falling and falling, as and how it starts cooling, the capacity to hold the water vapor will clearly start to fall. It will start to decrease. Okay. So the thing over here is that when temperature starts to fall, the humidity capacity decreases. Okay. We are not trying to add more water vapor to the mix. What we are trying to say is that when the temperature falls, अपने आप very naturally what happens is that the humidity capacity decreases. If the humidity capacity decreases, this relative humidity rises by itself. Then that is math, right? Agreed? So you are saying that as the denominator decreases, obviously the value will start to increase, the relative humidity will start to rise, and at some point of time it will become 100%. Okay, that point at which that saturation is reached, at that point at which the air is saturated with water vapor, we call that temperature as dew point. Okay, that temperature at which this happens is called as dew point. When cooling happens beyond the dew point when the air starts to cool, now the water won't cool, it will start to condense, meaning the water vapor will start to transform into proper liquid droplets. Okay, it will start to transform into liquid droplets, and that will lead to cloud formation. And when the clouds become too heavy to hold that water, it will rain down. Okay, it will rain down as precipitation. Is the process clear? Huh? Good. So what we are essentially saying is that relative humidity is important. It will. You ever seen a weather app? In your weather app, the first thing that you see is temperatures, minimum, maximum temperatures. They'll tell you which way the wind is flowing, what is the speed of the wind, and then they'll tell you what the relative humidity is, right? So clearly on a day when it is going to rain, the relative humidity starts to rise a lot, okay? Because the temperature falls. It is not like the temperature falls down at our level. We are saying as and how the air rises up, as the air goes up, clearly it will start to cool down. The humidity capacity decreases. Clearly saturation is reached, relative humidity is 100%. And then beyond that, whatever cooling is going to happen is going to ultimately result in condensation, okay? Is this clear to everyone? With me, everyone? Okay. So we are saying condensation happens if the air is cooled beyond the dew point, and both very high relative humidity and very low relative humidity are going to be a problem for you. Okay. Like if you have very low relative humidity, meaning the air is very dry. So you get those nosebleeds and all that sort of thing. That is a very problematic thing. And if it's very high relative humidity, you feel stifled. Remember when just before it is going to rain, you remember that feeling when everything feels very hot to you. You know that the temperature is not very high, but since the relative humidity is high, it feels like it is very hot. You know that's yeah, you know the feeling, right? That is very high relative humidity. Okay, very low relative humidity you don't usually witness in this part of India. You will have to go to northern India, a little colder place, to witness low. Leh Ladakh जाइए, सांस कम पड़ जाती है. You can clearly feel you do not have enough breath, right, to breathe. It is true that the density of air is much lesser in those regions because you are at a higher altitude and stuff like that. But there is also the problem that the relative humidity is low. It doesn't necessarily agree with your body. Okay, okay. So both will not be comfortable for us. Is that good? Samjha? Now you move to the different types of precipitations. We are going to look at in which form the rain falls. There are two ways to classify this types of precipitation. We are going to look at the way in which the rain falls. So we'll either call it as rainfall, snowfall, sleet, hailstones, like it, whether it falls down in the form of water or the rain comes down in the form of snowflakes or then maybe stones, like hailstones or something like that. In that sense, we classify it as rainfall, snowfall, sleet, or hailstones. And then the other way is the process in which the precipitation happens. Okay. So you are looking at convectional rainfall, the one that happens at the equator every day. Okay. Or then you're looking at orographic rainfall. We are looking at the kind of rains that happens in the Western Ghats or places like that. Or then the cyclonic rainfall, temperate cyclonic rainfall. Okay. We are looking at how it will rain in temperate cyclones. Okay. So these are the three ways in which rainfall might happen. So we are looking at precipitation over here. Okay, what is precipitation? You are saying moisture is released from above. Okay, where it is gathered in the form of liquid droplets. Clouds ke form mein the moisture is gathered over there. And when you release that moisture, after water vapor is condensed, it is converted into water. And when that moisture water is released from above, you call that as precipitation. Okay, okay. The very first way of looking at it is rainfall, snowfall, sleet, or hailstones. Okay. Now what happens is now the how do you say distinguishing criteria here is how the condensation happens. Okay, at which temperature the condensation happens. So, for example, you say if normally when the clouds are being formed, if the temperature is above freezing point, then clearly the water vapor will be condensed directly into liquid water. Okay, into water droplets, right? And when the freezing point is above water, when the temperature is above the freezing point of water, so in that case, then obviously rainfall is going to happen. Okay, the clouds will obviously hold water and rainfall will happen. In case of a snowfall, clearly when the condensation happens, when water vapor is being converted into, liquid, it is not necessarily converted into liquid because it happens below the freezing point of water. It will be converted into snow. Okay, so clearly वो snowflakes बनते हैं and precipitation will come down in the form of snowflakes. Okay, ठीक है, agreed. Sleet and hailstones are funny in that way. Sleet क्या होता है ना, शुरुआत में आपको what you get when the moisture is basically released, it comes down in the form of raindrops. Okay, then somewhere it comes down in the form of frozen raindrops. It is the precipitation, basically the condensation basically happens below the freezing point of water, below the freezing point of, wait a second ना, ये वाला ये फिगर देख लीजिए. See, this is rain, this is normal rain. कहाँ गया मेरा rain? है नहीं, snow ही दिखाया उन्होंने सीधा, कोई बात नहीं, frozen precipitation है. Look at this part, हाँ, sleet का जैसे हो रहा है, यहाँ पे frozen raindrops are released. Okay, over at this point when the moisture is actually released, it is in the form of frozen raindrops. Okay, now what happens is, now this passes through warm air. ये जो pinkish color का area दिखाई दे रहा है, the pinkish area that you see, that is a layer of warm air. Okay, so it passes through that layer of warm air, and hence what happens to those frozen raindrops? If they are going to pass through a little high temperature, they are going to melt. Okay, so those frozen raindrops, some of those frozen raindrops start to melt. Okay, and then again they pass through a layer of cold air. The bluish part of the air is going to be the cold air. Okay, so what happens is it passes through a layer of warm air, and then again it passes through a layer of cold air. So whatever raindrops had melted are refrozen again. Okay, so now this is a mixture of rainwater and frozen raindrops and stuff like that. Okay, melted rainwater and frozen raindrops. Sleet looks somewhat like this. See this? No. See this? No. This is sleet. Sleet looks like this. I don't know if you've ever. I mostly we live in the southern and western part of India, right? We don't get sleet over here unless it is raining really heavily, or then the temperatures have fallen really badly. Usually, if cyclones or something like that occur, then sleet is okay. But normally we do not get sleet. Okay, this is not something that we'll get over here. Maybe at higher altitudes you might get some amount of sleet, like not over here. I've rarely ever seen sleet over here in these parts of India. Okay, so this is essentially what sleet looks like. Okay, and this is what hail is going to look like. Okay, next thing that we are going to see is hail. So hail is those huge, it looks like stones, actual stones की तरह दिखता है वो. हाँ, frozen raindrops, but really frozen very badly. It is not so easy. Absolutely, because uh, what happens is those raindrops are now hail happens when the air rises very quickly upward. Okay, the temperature it becomes really high, and because of that extreme hotness, what happens is the air rises very rapidly above, so it is cooled down also very rapidly, and because of that, instead of freezing into instead of becoming water, condensing into water, the water vapor condenses directly into snow. Okay, and then you get a small little snowball. Okay, now what happens is there is still water around it in the cloud. Okay, that super cold water comes in contact with that snowball and it gets another nice covering of snow. Okay, so see how an onion is, it has multiple layers of that, right? So hailstones also have multiple layers of those frozen raindrops, and every time that layer adds, this hailstone becomes larger and larger and larger in size, and then ultimately it all rains down on you. Now clearly that is solid ice, so when it falls on your head, it is going to hurt. Okay, so right, it hurts window panes also, and glass windows of cars and stuff like that. Okay, so you are looking at hailstones like that. Okay, samjha, you get the difference between hailstones, sleet, snowfall, and rainfall. This is all precipitation. Okay, all of this is precipitation. Sleet causes damage to agriculture, especially fruits वगैरह जो होता है ना, cultivation of fruits and all, that is heavily damaged by grapes and everything. No, you usually get rains can also destroy that, but sleet usually will just uproot everything and everything. Like, that is not a good thing for agriculture, any sort of cultivation. Okay. The next part is how the rainfall happens, the process of precipitation. Okay, so we said there are three ways in which happens. One is the convectional rainfall, the other is the orographic rainfall, and next is the cyclonic one. Okay, so now let's look at the convectional rainfall. Convectional rainfall को convectional इसलिए बुलाते हैं. Remember, I had told you what convection is. We had said that when the air becomes warmer, it will rise upward, and then as and how it goes up, it will cool down. Right? That is why we are calling it convec. What is it? Water cycles के form में. Water cycle में that has to be, it is part of the water cycle, right? Because the water vapor has to rise upward, form clouds and then come down. That is the water cycle, and then ultimately it goes to the seas or the rivers or whatever. So that is where it is going to go. So that is it. It is part of the cycle. Okay. So we are saying convectional rainfall में what happens? Air becomes heated. Okay. On being heated, obviously it becomes lighter and it rises upward. Okay. Now when this air rises upward, it is going to become a little cool, okay, and it is going to expand. Obviously, why will it expand? Because clearly the density above is a little lesser. Remember, the air becomes less dense and less hot as and how you go away from the surface of the earth. Okay, okay. So clearly the air is going to expand. It is going to become lighter and it is going to become a little cooler also. Okay, what happens when the air starts cooling? अच्छा phone पे ना रहिए please. Get away from your phone. Sorry, you're not on your phone. What is so interesting in your hands, baby? Nothing? Awesome. Okay. You kids now, I really don't make any sense of you people. Huh? You are going to be so anxious now in September. You meet me in the first week of September and you are going to feel, यार कुछ नहीं पढ़ा है, कुछ नहीं आता है हमको. That is, and this is not just you. I'm not just talking about you people. I'm saying about everybody. Everybody else, all the kids that I've ever taught are very anxious just 10-15 days before the exam. At that time, you want to sit and study everything and you don't have the time for it. And I don't want to give you that, I don't want to put you into that pessimistic mode of mind where you are thinking that uh, things are going to go bad. But I need to warn you that you will not have time later on your hands, the time that you are wasting away right now, not paying attention, doing something else, not utilizing that time for something that could be used constructively. Unfortunately, it is all going to just pile up later on and you won't have enough time to deal with it. Anyways, back to business. We are saying that this air becomes lighter. The air becomes lighter, rises upward, expands, cools. Okay, what happens when the temperature falls? We clearly know that the humidity capacity decreases. Okay, if the humidity capacity decreases, obviously the relative humidity rises. Okay, what happens when the relative humidity rises? At some point, it is going to become 100%. The air is going to be saturated with water vapor. Okay, beyond that, if the air rises beyond that and the cooling happens beyond that point of time, then condensation happens. Condensation happens meaning whatever water vapor has now risen upward is going to turn itself into liquid droplets, okay, water droplets. And those water droplets are going to stick around. Usually the way the water droplets are formed is they are going to stick around salt or dust particles, and that is how those water droplets will be formed. And the collection of this water droplets is going to form a cloud usually. Okay, so this is how clouds are formed. So they keep on collecting those water droplets until by gravity, by the definition of gravity, it cannot hold more and the precipitation happens, then rainfall happens. Okay, so this is how it works. So there are two ways to look at it. One, you see that the air rises, it expands, the air cools. After a while, clearly the air will saturate and then condensation will happen, clouds will happen, and it will rain down. Okay, another way of looking at it is through the lens of temperature and pressure. You say the pressure decreases, okay, because clearly you're moving upwards, right? So clearly now the pressure has decreased, okay, the temperature has also decreased at this point of time, and clearly the relative humidity increases, and because of that precipitation is formed. It saturates, air saturates, and precipitation is formed. Okay, is this clear? Okay, so we are looking at this part. This is a regular occurrence in cumulonimbus clouds. Okay, sorry, we are saying यहाँ पे थे क्या? Oh, cumulonimbus are a kind of clouds जिनका vertical extent बहुत होता है. They look a little like a cauliflower, with a strong base. So it has a huge base, a flat base, and they look like a bit like a cauliflower, and they have a huge vertical extent. Like this is the way the clouds are formed. Especially when it rains a lot ना अपने यहाँ पे, तो इस तरह के clouds दिखते हैं. Like you have to watch them from afar to see how the vertical extent is. you can't stand beneath the cloud. Usually we are beneath the clouds, right? When it's raining. So you have to see them from a little farther to understand the vertical extent of the cloud. उनका vertical extent बहुत ज़्यादा होता है, and they definitely bring rains. And they are the kind of clouds that are formed with convectional rainfall. This kind of rainfall where the air generally heats up, rises, cools down, saturates, and then all that. उसमें ये clouds बनते हैं. These are the clouds that are formed. Okay, ठीक है? Next you move on to orographic rainfall. ये तो बहुत दफा किया है ना हमने. Now here normally क्यों convection rainfall में requirement क्या होता है कि temperatures बढ़े, है ना? The temperatures should see. The requirement over here is that the temperature should rise, because of which the air will heat and rise up and all that sort of thing, right? Okay, okay. So like we said, this will happen mostly at the equator. Okay, this is a regular occurrence at the equator. In equatorial regions, it will usually start to become very hot by the time it's 2 o'clock, 3 o'clock, and everything, because now the heat has, whatever heat has gathered is now working its way. Okay, so it is creating an effect now. So by 2 or 3 o'clock, it starts to become, you can feel the relative humidity rising, you can feel it is becoming very stuffy, and then finally around at 4 or 5 o'clock, it starts to rain. Okay, and it rains every day. Like out of 30 days in a month, it must rain for at least 25 days. Okay, so you're saying it is a regular occurrence in the equatorial regions, Rose ki Parish. Okay, but here in case of orographic rainfall, clearly it is not the heat that is making the air rise. Okay, we are looking at a barrier. Okay, orographic may, oro meaning mountain, so orographic rainfall meaning rainfall due to a mountain. So you're looking at a barrier. What happens is that the air is passing by, moist air is passing by a region. Okay, it comes across a barrier, and because it cannot go through the barrier, it rises upward. Okay, to go through, to ascend the barrier. So this is what happens to the air. You're saying that this is the moist air. It usually comes across a barrier. Okay, and then instead of passing through the barrier, because that cannot be done, it has to go above the barrier. Okay, it has to ascend now. So when this air ascends and rises, then the same effect is going to happen, right? Now the air has risen. If the air rises, what happens to the air? Clearly, it will become a little cooler. It will expand a little. If it is expanding and cooling, clearly it will saturate after a point of time. Once it saturates, what happens? It condenses. Okay, and clouds are formed, and it starts to rain. Okay, so this is exactly how condensation will happen while the air is ascending. Okay, and this will only happen while the air is ascending. What happens when the air is descending? What happens to the air when it is descending? Clearly now when the air is descending, the pressure will keep on rising. Okay, the temperature will also rise. क्योंकि compression हो जाएगा ना, air is descending. तो अभी compression हो जाएगा, and clearly now the pressure will increase, the temperature will increase because of the compression and everything. And what happens to the relative humidity? That also increases. If the relative humidity increases, what are the chances of precipitation? Less, right? Quite less. If the relative humidity if the relative humidity decreases, what are the chances of hush? You people also, boys at the back, stop talking, ma'am. So you're saying that as and how the relative humidity decreases, clearly the chances of precipitation also decrease, and at some point of time, then there is no rainfall at all. Okay, so you might get a little rainfall on this side, a small amount of rainfall on this side, but by the time the air actually comes down, katabatic wind बन के नीचे आ जाती है, तो वो clearly you don't get much. Okay, बहुत ज़्यादा नहीं मिलता आपको. Okay, is this good? Huh? That is orographic rainfall for you. So this region, see the region where the air hits, okay, this region. Mine is connected. I will never know how this works out for you. The region where the wind hits, okay, the part of the mountain where the air hits is called as the windward side, the side from which the wind is coming, okay, and where it is ascending in the first place, okay, and when the wind is where the wind is descending, that part of the mountain is called as the leeward side, okay, or the relief region, rain shadow region, as you call it, okay. Remember in school in geography, you used to always have that question that Bombay gets a lot of rain, but Pune gets less amount of rainfall. Bangalore gets a lot of rainfall, but Bangalore gets a less amount of rainfall, even though they are just 100, 150 kilometers away from each other. Okay, but still the rainfall is different, very different. The reason being because both Bombay as well as Mangalore lie on the western side of the Western Ghats. You're talking about this region. Okay, these are the Western Ghats, right? Huh? The southwest monsoon, दिख रहा है ना आपको? हाँ, southwest monsoon winds come from the Arabian Sea towards the Western Ghats, okay, in this direction. You're saying they come in this direction. Now what happens is that Bombay and Bangalore lie on this side, okay? They lie on the western side of the Western Ghats. So clearly they lie in the windward region, and that is why with that ascending air, they clearly get, both these places get a lot of rainfall, okay? On the other hand, Pune as well as Bangalore lie in the rain shadow region or the relief region. So on the leeward side, so clearly they get a little less amount of rainfall, okay? ठीक है, ये याद रहेगा with orographic rainfall. Okay, ठीक है. Last type of rainfall is going to be a cyclonic rainfall. Okay. Now we are not looking at tropical cyclones because tropical cyclones will form rainfall mostly like convectional rainfall. Okay. Like how the condensation over there happens like the way it happens in convectional rainfall. Okay. For temperate cyclones, the process is going to be slightly different. Okay. What you say is in temperate cyclones, what you need is two air masses. Okay, of contrasting qualities. Okay, so if there is a warm air mass and there is a cold air mass. Okay, usually like say suppose if you're looking at the world like this, okay, and this is the equator. ये ब्राजील का shoulder है. I'm not very good at drawing, so I'm just going to say this is the equator. Okay, ठीक है. Now what happens is now that in say suppose this is the tropical region, right? We are saying अभी 23 कहाँ आएगा यहाँ पे? नीचे का मैं नहीं ड्रॉ कर रही हूँ. This is enough. So we are saying usually what happens is where how temperate cyclones are formed is that warm air mass usually comes from the tropical regions, okay, somewhere closer to the tropics, and cold air masses come from the polar regions. Okay, that is what we are saying. So warm and cold air masses come together. You understand what an air mass is? It is huge mass of air that is carrying the qualities of the land that it was in. Okay, so if what is it was developed in a cold place, then it will carry that cold properties, that the air will be a little colder, the air will be a little drier, so on and so forth. Okay, and warm air masses will usually be a little more moist. They will have higher temperatures, but it is generally a whole huge column of air, a whole huge mass or block of air that will usually have very homogeneous temperatures and humidity throughout. Okay, that is what we are saying in the air masses. So we are saying there will be a warm air mass and a cold air mass. Okay, and then they meet. Okay, they meet at some point of time. Now, when these warm and cold air masses meet, what happens is that a front is formed. Give me a moment. हाँ जी, सृष्टि अच्छा. Okay, दिख रहा है आपको? You're saying there is a mass of warm air and there is a mass of cold air. Okay, they come from opposite directions and then they meet at some point of time. Okay, now when they meet, can you see this front that is formed over here? Okay, this is called as a front. The boundary or the transition region between them, the interface between the warm and the cold air masses is called as a front. Okay, and the process of forming a front is called frontogenesis. Okay, इसके ऊपर questions आते हैं, please ध्यान दीजिएगा. I'm going to explain to you properly what tropical and temperate cyclones are, but try to understand what I'm saying now. We are saying there is a warm air mass, there is a cold air mass, both of these meet, and the point or the interface of boundary at which they meet, you will see the formation of a front. Okay, it's called as a front. उसको technical नाम होता है front. Okay, if the warm air is pushing the cold air, then a warm front will be formed. If the cold air is pushing the warm air, then a cold front will be formed. Okay, but such a front is formed. Okay, now what happens over here is that since the warm and cold air are going to intermix and intermingle, what happens is condensation will happen, right? The warm air, the water vapor in that warm air, it is going to be condensed, right? It is going to, the water vapor is going to turn into water droplets, okay? And then clouds are going to be formed and clearly it is going to rain. This is a very, very simple process of actual condensation in temperate cyclones, okay? Okay? What is the property of cold air? What does cold air try to do all the time, or cold water? It tries to sink, right? And stay below because it is heavier, it's denser. So in this kind of case also, in the case of a temperate cyclone also, all the time that the cold air is trying to do is it's trying to push the warm air upwards and settle beneath the warm air. Okay, that is all that the cold air is trying to do. Throughout, जब से first moment से लेके last moment तक, the cold air is trying to settle downwards, push the warm air up and just settle over there, okay, beneath the warm air. So when that finally happens, when the cold air lies below and warm air lies above, what will happen? Atmospheric stability, right? The warm air is not going to rise anymore. No more clouds, no more precipitation. So, and since that atmospheric stability is reached, clearly you will have no more rainfall. Okay, okay, fine. So that is how the temperate cyclone dissipates. खत्म हो जाता है वो. Okay, चलेगा? So this is what temperate cyclones are. Cyclonic rainfall is usually, when we study cyclonic rainfall as a kind of rainfall, as a type of rainfall, it is usually the temperate cyclone type of rainfall. First of all, there's a warm air mass, there's a cold air mass. They will meet together, a front is formed. Once the front is formed, the cold and warm air mix, intermingle, condensation happens, and obviously it rains. And finally, at some point of time, the cold air is going to push all the warm air upwards. It's going to settle downwards, and with that, the temperate cyclone dissipates, and no more rainfall after that. Okay, ठीक है? उसको ना occluded front बुलाते हैं. When the cold air completely replaces the warm air and settles beneath it, that is called as an occluded front. Occluded means something that is blocked or stopped. That is what occluded means. You guys have English also, na? So occluded means something that is blocked or stopped. Occluded arteries, occluded arteries. That's a thing with biology, right? When a lot of cholesterol lines up or air lines up into your arteries, then that is occluded arteries, arteriosclerosis. Correct. Hardening of arteries. That is a different thing altogether. Good so far? हाँ, सारे precipitation समझ आ गए? Good. Hindi बिल्कुल. You do not understand Hindi at all? When I say समझ में आ गया, do you understand that, Fatma? अच्छा, थोड़ा समझ आता है. Good. चलेगा. All right. Next, moving on to types of condensations. Okay. Condensation is different. Condensation is, I'll tell you what condensation is. In a proper hot summer day, take out a bottle of Coke and keep it outside. What the water droplets formed on the surface of that water bottle is condensation, right? Agree? Or then the kind of things that you see when early morning, on a winter morning, a nice early winter morning, if you are sitting inside a car, you can see the condensation outside the window bay, right? That is condensation. So essentially what is happening is the water vapor is going to convert itself into water droplets, okay, liquid water. So that will be called as condensation. Condensation is transformation of water vapor into water, okay. Now condensation is caused by the loss of heat. Heat is lost, no? And that heat which is lost is the energy released in that process is called as latent heat of condensation, okay. This is what we studied in school back in physics, no? Like this is a proper question in your 20 questions in geography. PYQs में question पूछा जाता है, what is latent heat of condensation? So it is the energy released in this process, okay? Okay. So now we are saying condensation can happen in three ways. One is when the water vapor in the air cools around small hygroscopic particles like dust, smoke, or salt. The way clouds are formed, the way normal clouds are formed. The water vapor will cool around dust or it will cool around salt particles, something that is hygroscopic, something that can hold water. Okay. You need a stable holding place, na? A placeholder to chahiye na aapko. So clearly that will serve as that. You will the dust or the smoke or salt particles will hold on to the water vapor and it will contain the water. It will hold the water, not contain the water. It will hold the water with itself. Okay, so that way condensation can happen. Then the second thing is a moist air is in contact with a colder object. The Coke bottle example that I explained, right? The Coke bottle is cold. The surface is clearly cold. Okay, but when you keep it in the air around is clearly moist and warm. So the moisture from that warm air is going to condense on that cold surface. Okay, that is going to happen. And lastly, when the temperature is close to dew point, then condensation can happen, right? If the temperature is beyond dew point, close to dew point, clearly condensation happens beyond that point. Cooling after that is going to result in condensation. So these are the three ways in which condensation can happen, okay? And condensation will depend on volume, temperature, and pressure, all of these things, right? If clearly pressure, temperature, and volume is important, right? Relative humidity of air is important. What happens when the use of sitting at the very back? I don't know your name. You know you're sitting at the back, right? Stand up, people sitting at the back. No, not you. You sit up. The guy next to you, is he not sitting at the back? Are you sitting in the front, sir? No, you were. No, you weren't. Okay, now tell me, what happens to air if the relative humidity of air increases? So what are the chances for condensation? If the relative humidity increases, does condensation happen earlier or later? Blue shirt, same question. If relative humidity increases, what are the chances of condensation? guy diagonally behind you? The guy who is sitting diagonally behind blue shirt. What are the chances of condensation if relative humidity rises? Relative humidity increases. Increases. The chances of condensation are higher. Clearly, it can condense if relative humidity increases. Uh, okay, sit down. Good question. Good answer. Second question. Will dew point be reached quickly or later if the relative humidity rises? You say at the very back. Hmm. Next time you talk in my classroom, I'm going to ask you to leave. Huh? I've always suggested you might sleep if you want. You catch up on your sleep. I don't care. But do not disturb the classroom when I'm teaching. Sit down. Here we are. So we are saying that clearly, as and how relative humidity will rise, if the relative humidity rises, clearly condensation can happen. And if the relative humidity falls, the chances of condensation become blurrier and blurrier. Okay, it becomes a little less. All right. Okay. Now condensation can take place when dew point is either higher or lower than the freezing point. Does it have to be at the freezing point or higher or lower? It can happen at any case, right? The condensation can turn water vapor either into snowflakes or it can turn water vapor into water droplets. Either of these things can happen. No, clouds can contain of ice droplets or as ice crystals, as well as clouds can contain water droplets as well, right? It is not like clouds can only contain water. Icy clouds भी तो होते हैं, icy crystals जो contain करते हैं वो, right? So clearly condensation can happen below or above freezing point of water. You guys got to remember all this. Huh? The reason why I've listed everything, what will seem logical to you, I have listed almost every single point. The reason being because when asked in exams, you do not know how to turn your head that way. Okay? Okay? Now we look at the various types of condensation. And please, yaad rakhiye, please remember all this because UPSC tends to ask you which of these is a condensation, which of these is a precipitation. So you need to know that sleet is a form of precipitation, dewdrops is a form of condensation. So, or frost is a form of condensation, huh? That you need to remember. So these are the 5 types of condensations that you're looking at. Dew, frost, fog, and mist, and clouds. Clouds so hote, okay? Okay? So dew first, huh? Water droplets formed on cooler surfaces, like we discussed, window panes, water droplets formed on window panes, or on, the surfaces of leaves, no? Leaves fade. Usually what happens is the leaf is the colder surface, the air around it is a little warmer, so it will clearly become the water droplets, the water vapor from the air will condense on it and clearly condensation will be formed. Okay, that is called as dew drops. And it occurs when the dew point is above the freezing point of water because now the conversion is in the form of water, okay, instead of snow. In frost, clearly the conversion is in the conversion of water vapor is the water vapor is converted to snow, right? Okay, ice crystals, not snow, ice crystals. So the moisture is condensed into ice crystals, and it occurs when the dew point is below the freezing point. Okay, at or below the freezing point, clearly. Now the third type of you've seen frost. No, we've seen frost. How frost looks like, right? Now the third thing is fog. Okay, fog is kora. Kora. Okay, we have two things over here. One is the fog. The other is mist. So fog is, I don't know the Malayalam. You understand Kora, right? And you understand Dhund. Dhund samajh aati hai aapko, right? Dhund and Kora. We are looking at two different things. So fog is when the water vapor condenses around fine dust particles. There have to be dust particles around it. Usually happens on after a long winter night when the temperatures fall really, really low. The water vapor condenses because of the low temperatures. The water vapor condenses in the form of water droplets, and these water droplets are left suspended in the air. Okay, the air that you are walking in. Sometimes you feel the coolness of the water, but if you check your hands, you can't see that any vapor or any moisture anywhere, right? So that is the water vapor that you're coming across. Okay. So we are saying that this condensed water vapor or this condensed water droplets are simply suspended in the air, and that is what we call as fog or mist. Okay, if the amount of water vapor is a little more, then we call that as a mist. If the amount of water vapor is a little less, we call that as fog. Okay, and both are not very good for driving, right? Because they affect visibility a lot. This can, if the fogs and mists are formed a little, this can affect, this can cause accidents on highways and stuff like that, especially in the northern part of the country where temperatures can fall really low. Okay. Secondly, fogs and mists are not a very welcome thing for low flying airplanes also, helicopters, choppers, like those kind of flying things. So they are not very good for that either. Okay. Okay. Lastly, you go to clouds. Clouds जो होते हैं, that is water vapor has condensed into water droplets or ice crystals. Okay. So either of this. Now, if the condensation happens below the freezing point, then obviously it is going to be ice crystals. And if the condensation happens above freezing point, the dew point is above freezing point, then clearly it is going to be water vapor. Okay. And then water droplets. And then that is how clouds are formed. Okay. And that will ultimately result in whether rainfall happens or sleet or hailstones happen. Okay, that how the precipitation is going to come down. All right, clear so far? Huh? We have discussed what the different types of humidity is. Three different types of humidity, and we've seen the different types of precipitation and the different types of condensations. Okay, okay. Now you move on to the different types of clouds. We are going to look at various types of clouds. Good. Okay. These are the various types of clouds. You're saying clouds जो होते हैं, they can be either made up of tiny water droplets or they can be made up of ice crystals. Okay, the condensation has to happen around hygroscopic nuclei. Hygro meaning water, scopic meaning something that will attract it. So we are saying that hygroscopic nuclei meaning something that will attract water. So dust or salt particles that we are saying. And that is caused by what happens, the air is lifted up and cooled, and after that condensation can happen, right? So that is the process. Now clouds to generally classify करते हैं as on the basis of their position, okay, location. So if they are at a high altitude, they are called as high clouds. They will be called as middle clouds or low clouds. Okay, that is the general classification. They are looking at the high clouds. Look at all these high clouds. They are a little thin, clearly wispy kind of clouds, right? You can see these now. All of these clouds are a little thin in nature. So the first cloud that you are looking at is cirrus. Cirrus are thin, wispy, feathery, fair weather clouds, right? These can never bring rain. If you see these in the sky, you know rain is not coming today, right? Clearly know that. So these are always white in color, and that is because of because they are fair weather clouds. They're not bringing you any rain, okay? Cirrocumulus. Cirrus meaning now ringlet. Cirrus is the Latin word for it is ringlet. It comes from the curls of hair. That is this for it. So they are usually thin, wispy. That is why the name Cirro. That is why the name will be everywhere, because thin, wispy, a little like a ring, that sort of thing. So cirrocumulus is, now you can see those little bunches of those fluffy clouds, right? Scattered and bunches, right? So it appears as white globular masses like ripples of sand, right? It looks like ripples of sand. This is also called as mackerel sky. I don't know how you're going to make the connection now, but let me try. मेरे mackerel कहाँ गए? Oh, I lost my this is mackerel. See, this is mackerel fish, okay? This is how mackerel fish looks like. Okay, I don't eat fish. I don't know what this is called in local language. Mackerel looks like that. So if you see over here, if you see mackerel, they are placed in lines. So if you place these clouds like that, they are going to, if you place the fish like that, the clouds appear like mackerel fish. Okay, like they are like the mackerel are placed. That is what geographers have thought. If you do not think that it is perfectly okay, just remember that is called as mackerel sky. Cirrocumulus clouds are called as mackerel sky. Okay, okay. Next is cirrostratus. Okay, stratus meaning what? Layer. Okay, so cirrostratus is going to be that thin layer. So we are saying it looks like a thin white sheet or veil. Okay, it looks like that. And usually you can see the sun or the moon shine through with a halo in these kind of clouds. Halo दिख रहा है ना यहाँ पे? वो sun का halo दिख रहा है ना आपको clearly यहाँ पे, है ना? So if you look at the sun through these clouds, you can clearly see the halo. You can see the wing of the airplane also from where the photograph is taken, right over there. So clearly you can make out what this it is. It looks like a nice normal veil. ऐसे पर्दे की तरह दिखता है. It looks like a small veil, a thin veil, and you can see the halo of the sun or moon shining through it. Okay, that's what the cirrostratus clouds are famous for. Okay, cool. These are high clouds. These high clouds are usually formed at a height of some 20,000 to 40,000 feet from the surface of the earth, okay, above the ground. Now you come to middle clouds. Middle clouds are usually formed around 7 to 20,000 feet above the ground, okay, so a little lower than the high clouds. 7 to 20,000 is low. Okay, middle. Okay. So वहां पे अभी, and these clouds usually begin with the name alto. Okay. So they are called as alto stratus, alto cumulus. Stratus meaning clearly it will look like sheets. You can clearly see, no, the alto stratus clouds look like milky sheets, grayish clouds होते हैं, denser with a watery look. Okay, but they look a bit like layers and sheets. All right, that is alto stratus for you. And alto cumulus is going to look like bunches, little bunches. Okay, woolly, bumpy clouds which appear like waves. That is alto cumulus for you. Okay, yes. No, they are formed way above. They are formed 20 to 40,000 feet above. Cumulus, there are normal cumulus clouds also which are formed in low this. Now you have to check out the height now. So if they are formed very high, then they are clearly going to be cirrocumulus. The higher clouds are called as cirro, right? So you call them either cirrus or you call them cirrocumulus or cirrostratus, depending on whether they are in bunches or whether it's a thin sheet or simply wisps of clouds. Okay, so that will decide whether they get called cirrus or cirrocumulus or cirrostratus. If you come to the middle clouds, then they are famously called as alto. If that is, if you, there you find a sheet, a little denser sheet over here, then that you called as alto stratus. If you find them in the form of waves, and this looks different, right? This looks a little different from this. Nahin? Yes, Asura, this looks like a desert kind of a thing. No? है ना, सैंड नहीं लग रहा है डेजर्ट की तरह, नहीं आपको नहीं लग रहा है? मे बी आई एम जस्ट यूज्ड टू सीइंग टू मेनी क्लाउड्स. This looks a little different, and you can, they look bumpy, woolly. They look heavy also. They definitely look a little heavy. Wait a minute. ये स्ट्रैटोक्यूमुलस है, right? ठीक है? Okay? No? Okay. Go back. And we are on. ठीक है? Okay, these are altostratus and altocumulus clouds. Okay, and lastly, you come to low clouds. Okay, low clouds meaning those which are formed below 7,000 feet. Okay, so which are really close to the ground surface. You're looking at those clouds. Okay, so now they can be, those are called as stratus or strato. Okay, so there is the stratocumulus clouds. Those are rough, bumpy clouds. You can see a direct contrast also, yeah, between the white and the black parts of it. Yes. They do tend to move faster. Sometimes, especially if the wind is helping, if the rains are happening somewhere, stratocumulus sometimes moves faster. Agreed. Okay. And stratus clouds, yeah. No, these. There is a separate section of rain clouds. You're looking at a different section of rain clouds. You're not happy with the answer, no, Padma? Here we are, stratus. Stratus clouds, these can be very dangerous clouds of people. These are low clouds, okay? They sit low, especially on hilltops or something like that, okay? And they're uniformly gray. They can be really gray and thick. And they can reduce visibilities for aircraft. So you've ever heard of all those aircraft crashing in places like, what is that famous Devi ka thing over there? Kullu में क्या है वो? अरे we go ना माता का दर्शन करने कहाँ जाते हैं? वैष्णो देवी, राइट? सो वहां के हिल्स का, या फिर यू नो सम प्लेस इन वो जो पूरा उत्तराखंड का जो टूरिज्म एरिया है, या on which side? Nashik hills also have these kind of clouds. Yeah, they do have a training center there. Yeah, absolutely. It feels like fog. It feels like a low sitting fog. Okay, so this is, and it feels like a permanent fog. These clouds can be very dangerous. Stratus clouds. Okay, if you're looking at movies, this is exactly the kind of cloud when you start a movie जिसमें बहुत बड़ा murder mystery निकलने वाला है आगे, right? This is exactly the kind of place. ऐसे dark clouds sitting low on the hill, and then somebody screams, "Kya!" and then now you know that a murder has happened, right? So we are looking at that. So these are stratus kind of clouds. Okay. So clearly reduces the visibility of the aircraft, hence can be considered dangerous. Low sitting clouds. Okay. Low lying clouds. They sit low and they are very thick and uniformly gray and thick. Okay. ठीक है, चलिए. Now you are looking at proper rain clouds. Okay. Rains जिसमें आते हैं वो वाले clouds. First is cumulus clouds. Okay, cumulus mane bunches. You can see those huge bunches of clouds. Okay, it's a vertical cloud, rounded top, horizontal base. So you will usually get a rounded top and horizontal base. Typical of humid tropical regions. Okay, like we discussed, convectional rainfalls. Convectional rainfalls are associated with cumulus or cumulonimbus. Okay, we are looking at those two clouds. So it's mostly a fair weather cloud, but if it has to rain, then it can bring rain also. Okay, but mostly fair weather. Mostly fair weather. Okay, cumulus. Next, you come to nimbostratus, and these two are important: nimbostratus and cumulonimbus. Nimbus itself means you've seen Harry Potter, right? Remember what his this thing was called? The flying broom. It was called as Nimbus 2000. How can you people not remember these things? You never saw Harry Potter, or I don't know. I've seen the movie so many years ago, and I still remember Harry and his broom. What? Monkey King? The Jet Li film? No. Hey, no, I have not seen the animated version. He also has a Nimbus, something. Acha, he carries a Nimbus cloud with himself. For the monkey king. No wonder he is considered so respected in most circles. Anyways, Nimbus itself means thunderstorm or rainstorm. Okay, okay. So nimbostratus meaning now you're going to have a layer of that rain cloud. Okay, you're looking at a layer of the rain cloud. It is usually dark, dull, layered cloud. This is the cloud that is associated with cyclonic rainfall, temperate cyclones, the ones that happen outside of India. Okay, so we are saying this nimbostratus is also usually it brings continuous rain, snow, sleet, whatever it's going to bring, it's going to happen continuously. Okay, for a long period of time. You see how low it is sitting. You see how widespread it is. Clearly. Next, you look at cumulonimbus clouds. This is also associated with cyclones, but mostly convectional rainfall or tropical cyclones. Okay, cumulonimbus is the cloud that essentially brings you rain always and always. Okay, its a vertical extent could be anywhere between 2,000 to 30,000 feet. Okay, that high those clouds can be, and they usually start from very low. Okay, so you can clearly see it goes up, and this is a very filmy type of rainfall, heavy rainfall, thunder, lightning, and all that sort of rainfall is what to happen. Okay, samjha humidity. You got humidity, huh? Okay, good. Now we move forward. Which of these is not a favorable condition? नहीं ये नहीं कर सकते ना ये तो आपको सिखाया नहीं ये you miss that part. Can you answer this question? With which layer of the atmosphere is occurrence of auroras associated? You've done this before, but I don't think I've done this with your class. Oh, what are auroras? Auroras are the displays of light. Auroras नहीं पता. Auroras नहीं चाहिए. This, not the singer. You can see the display of light, right? This is called as an aurora. Okay, so this usually happens in the thermosphere. This is a thing from the thermosphere. Okay. हाँ thermosphere में होता है. Thermosphere में होता है. I'll just stick to whatever is happening in this because then I have to, because we have not you guys have not done temperature inversion or earlier part of the atmosphere with me ना, then रहने दो. ये वाला बताइए. Wait a minute. I need people to answer this now. Balloon shot. नाम क्या है आपका? हाँ अथर. Okay. अथर मुझे 7th का आंसर बताइए. The temperature at which air is saturated with water vapor is called latent heat of condensation, dew point, boiling point, or convectional precipitation. Absolutely correct. The temperature at which air is saturated with water vapor is called as dew point. Okay, relative humidity becomes 100%. The temperature at which the relative humidity becomes 100% is called as dew point. What happens beyond the dew point, if the further cooling happens, that will result in condensation. What's latent heat of condensation? The energy that is released when condensation happens. Agreed. Absolutely correct. The energy that is released when condensation happens is called as latent heat of condensation. दिखता नहीं है ना आपको वो energy release हो गया है. Boiling point होता है at which the water or any other liquid is going to boil. And convectional precipitation is that kind of precipitation in which air rises because of heat, because the temperature gets high, the air rises and then normal water cycle में जो होता है वो वाला. Okay, ठीक है. ये हो गया था, ये हो गया था, टेम्परेचर इन्वर्जन कर लिया था, ये वाला बताइए. Which of the following statements is incorrect? इसमें से कौन सा statement incorrect है? Absolute humidity is the actual amount of water vapor present in the atmosphere. Relative humidity increases with increasing temperature. Dew point is the temperature at which relative humidity equals 100%, and specific humidity is called P for Bombay. Correct. Relative humidity decreases with increasing temperature, right? And it will increase with decreasing temperature. Either way will work. Okay. Absolute humidity is the actual amount of water vapor present in the air. Dew point is at which that air is completely saturated with water vapor, and clearly relative humidity is 100%. And specific humidity is called as the geographer's yardstick because specific humidity does not change with temperature. Okay. ठीक है. ये वाला 13th question. Which of the following is a type of precipitation? Absolutely. The rest of those three are condensations. Okay, fog, mist, and dew is condensation, is a form of condensation. Hail is a form of precipitation. Okay, ये वाला great question. मुझे बहुत अच्छा लगता है. बताइए. Which of the following type of rainfall and the seasons or regions that are available? Relief rainfall, convectional rainfall, and frontal rainfall. And the three regions or seasons that you will be given are Meghalaya Plateau in southwest monsoons, Punjab in winters, and Konkan coast in pre-monsoons. Meghalaya is a plateau, right? Clearly. No. And for convectional rainfall, what is the prerequisite condition for convectional rainfall? Temperature needs to be very high. Otherwise, the air is not going to rise, right? So now you need very high temperatures. Where will you get very high temperatures in Meghalaya, Punjab, or Konkan in pre-monsoons? 2C, 2C. Oh, correct. Convectional rainfall is going to be Konkan coast in pre-monsoons because the temperature in Konkan coast is going to be really, really high, right? We've been there, right? We've all been to that part of the world. So we know that Konkan coast is going to have really high temperatures in pre-monsoons. And what you get over there is that Amrasari and all that sort of thing. Nahin? You've never heard of that? Those pre-monsoon rainfalls jo milte hai. Hot temperatures, when the temperatures, you get a little, huh? Mango showers, right? So that is going to be the Konkan coast in pre-monsoons. Or then Kal Baisakhi in West Bengal, the same thing. It is the same thing. All of these are pre-monsoon showers, okay? So that is convectional. Relief is going to be now you have come across a barrier and you have crossed the barrier and clearly the other side is not going to get more rainfall. Which of these can be a barrier? Can Punjab be a barrier? No, it is going to be the Meghalaya plateau, right? The Meghalaya plateau, this is the Meghalaya plateau over here, okay? Where is India? India. दिख रहा है ये गारो खासी जैंतिया hills? That's your Meghalaya plateau, okay? The southwest monsoon winds are going to go this way. They're going to go straight over here and they're going to go and be obstructed. They're going to collide against the Meghalaya plateau. Obviously, the air is going to rise and ascend. Okay, so on this side, on the southern side of the Meghalaya plateau, clearly you get a good amount of rainfall. But when you cross over and go to the other side, then obviously that's going to be relief rainfall. You're not going to get much rainfall on the other side. Shillong lies there. Okay, okay. Where were we? Here. Okay. So we are saying relief rainfall is Meghalaya plateau and frontal rainfall is going to be Punjab in winters. What happens is in Punjab, this is Punjab over here. Can you make out? This Punjab. Okay, this is Punjab over here. Okay, this is Punjab in India. Okay, we are looking at a season of say December, Jan, November, December or Jan. Okay, so now this is usually Lodi ke time pe you have the harvest. So 14 Jan, somewhere in the middle of Jan, you're going to have your harvest. Okay, wheat harvest. So just before that, you will get slight rainfall, slight showers of rainfall, which are very good, which is considered really good and beneficial for wheat. Okay, wheat requires that slight rainfall, slight showers just before the harvest. Okay, so what is happening is over here, a temperate cyclone will be developed over here. Okay, depressions बुलाते हैं उसको, western depressions बुलाते हैं अपने यहाँ पे. So वो यहाँ पे develop होते हैं. These are developed in the Mediterranean. This is the Mediterranean Sea. Okay, so they are developed over here. They travel all the way through this region, this Iraq, Iran, and Afghanistan, Pakistan, and all, and then they come over here to India, okay? And they give these slight showers, which are extremely beneficial to us, okay? So we are happy with that. So we are saying, what is the answer here then? Relief is clearly A. Acha, B. A, C, B. है ना? हाँ, A, C, and B. Very correct. Correct. Okay? ठीक है, B. Answer should be B. टेम्परेचर इन्वर्जन नहीं कराएंगे. टेम्परेचर ये वाला बताइए. Which of the following depends upon temperature? In this specific, which is more of a suitable answer? Specific does not depend. Total humidity will depend. Absolute will also depend a little. But which is the one which is most affected by temperature? Relative. Relative humidity is the one that is most affected by temperature. क्यों नहीं? See, specific humidity does not get affected because it is mass versus mass comparison, right? Agreed? Absolute humidity may get affected because it is mass versus volume comparison, okay? But you are anyways calculating absolute humidity at a definite temperature. You're saying absolute humidity at this definite temperature, okay? But relative humidity is going to rise and fall with rising and falling temperature, okay? So if the temperature rises, clearly relative humidity falls. If the temperature falls, clearly relative humidity rises, okay? So clearly that is going to be a problem. So we are going with relative humidity. That is the most, that is more probable as an answer, most suitable. Yeah. Coral reefs नहीं कर सकते, meteor showers नहीं कर सकते, atmosphere नहीं करा सकते. Okay. Now we move on to this part. These are PYQs. ये हमने एटमॉस्फेयर का कर लिया था पहले, so I'm not discussing that again, all over again. This was also discussed earlier. We haven't. Did I explain Coriolis effect to you guys the other day? I did. No, I didn't. I did not to some. Okay. Winds नहीं कराएंगे. ये भी नहीं कराएंगे. ये भी, ये क्या है? Coriolis effect नहीं. Auroras नहीं. ये वाला बताइए. Which of the following statements regarding clouds are correct? Clouds are classified on the basis of their altitude and their form. According to altitude, they are classified as high, middle, and low clouds. Stratus, nimbostratus, and stratocumulus are high clouds. First 1 and 2 are correct. Agreed? Clouds are classified on the basis of altitude and form. Clearly, if they are wispy or something, they are high clouds, and clearly we are going to classify them. And based on the altitude, we call them high, middle, and low clouds. And stratus, nimbus, and stratocumulus are low clouds. High clouds are usually cirrus, and middle clouds are alto cumulus, alto stratus, and low clouds are stratus or stratocumulus. That is what we are calling them. Okay. High clouds are cirrus, cirrocumulus, and cirrostratus. You want a break? We finished. Wait a second, now. Just give me one moment. Let me check if let me finish all the questions for humidity, then you take a break, then I'll begin pressure, because I need to at least start something with pressure today. Just let me finish the questions, okay? Which of the following statements regarding humidity are correct? It is the ratio between actual amount of water vapor present in the atmosphere and maximum amount it can hold at a given temperature. Yeah, when the relative humidity is high, more water evaporates from the skin. Yeah, if it is becoming more saturated, na. The air is, if the relative humidity is high, then the amount of water vapor present is more. So will it try to take more water vapor? No. When the relative humidity is low, then yes, then that is possible. Okay. So second statement is not correct. We are saying that the second statement will not be correct. Okay. First is correct. The first statement is correct. This statement is correct. This is ratio between actual amount of water vapor present in the atmosphere. That is absolute humidity, and maximum amount that it can hold at a given temperature. Okay. No, that is relative humidity. Sorry, that is the definition of relative humidity. absolute humidity versus humidity capacity. Okay, this statement is wrong. That if the relative humidity, see, if the relative humidity is high, then clearly the more amount of water vapor is being held. Now, can more water vapor be added to that? No, this will be less. And higher the air temperature, lower the relative humidity. Yeah, relative humidity and temperature are crisscross, right? Inversely related. So yeah, so we'll go with 1 and 3. Hmm. Uh, yeah, a minute. ये वाला बताइए. According to the Indian Meteorological Department, which of the following is our features or features of the cloudburst? Okay, cloudburst चाहिए अभी आपको. Heavy precipitation in short period of time in a limited geographical area, and it occurs generally during monsoon period and triggers flash flood and landslides. Yes, both are correct. You are saying cloudburst is essentially that a huge cloud literally bursts above a single place. So localized rain, that is the thing with cloudburst. See, if we had a good amount of rainfall over a larger period, a larger space, then clearly what happens is there is a lot of seepage, right? A lot of water is precipitated downwards and goes and adds to the water level. The runoff will be less. Okay, the surface runoff will be a little less because the water does not gather over there for a long time. Okay. In case of a cloudburst, what happens is that even if the place has great absorption tendencies, if you pour a large amount of water, how is that water is going to run out mostly, right? The surface runoff will be greater, and because the surface runoff is greater, hence you will have flash floods and landslides and stuff like that. Okay. Okay. So both are correct. That you get a heavy amount of precipitation in a very short period over a very small place, over a local, like that thing that happened with Kedarnath, right? That was a cloudburst. Ladakh, Kedarnath ka tragedy yaad hai some few years ago. Yeah, that was the cloudburst. Even that thing was a, yeah. उसकी वजह से ही flash floods हुए ना, because what are flash floods when a huge amount of water is present in a place and all that is converted into a surface runoff. So it's the water simply starts running off over the surface. That is what you're saying. So that can only happen if it is not spread over a large area. If it's spread over a large area, then clearly it will be absorbed in the soil. Cherrapunji also gets a lot. Yeah, that is a different case altogether. That is the rainiest place on the earth, and there are soil issues also over there, right? Because it has been raining consistently for so many years there now. So that is a normal thing there. How much absorption can happen over there? And mostly it is rock, right? It is Meghalaya plateau, so you're looking at rock instead of soil. So that's a different thing. So both statements are correct. Yes. No. Yeah. Which one of the following is not a form of condensation? Sleet is not a condensation, it's a kind of precipitation. Dew, fog, and frost are precipitations. Sleet is not a condensation. Which, sorry. Which cloud is a rain-bearing cloud? Nimbus. Nimbus is going to be a rain-bearing cloud. Very correct. Yeah, but it's mostly fair weather. It may give rains, but it is mostly fair weather. And if you have nimbus in the list, then no point in going towards cumulus. Nimbus means thunderstorm. Yeah. Air masses, nahi. ये वाला. Inversion of rain, convection, cyclonic rainfall, या फिर cyclonic rainfall, tropical temperature. Which one of these? Inversion of rainfall is orographic rainfall. Very correct. See, the thing with orographic rainfall is, you're saying 6 is because this is the mountain, okay? And this is, I'll explain. We are saying that this is the wind, okay? The moisture starts to ascend over here, above this barrier, okay? So it will start to, the moment that condensation happens, it will start to give rainfall, okay? So it starts to rain over here, but only up to a certain altitude, okay? Above that altitude, when you start to go more and more further upwards, when the wind starts to ascend more and more, clearly the rainfall starts to decrease in this section. In the higher sections of the mountain, the rainfall starts to decrease, and that gets called as the inversion of rainfall. Okay? Huh? No, it will not snow. The amount of rainfall will become lesser. Because the temperature has to change. The temperature has to be below the freezing point. The precipitation, it may snow as in how you go higher, like in the Himalayas, it may snow. But we are saying that essentially the amount of precipitation received will not keep on increasing. It will keep on dropping after a certain altitude. Okay, so that is what we call, that process is what we call, the phenomenon is called as inversion of rainfall. Which of the following clouds is characterized by continuous precipitation? Continuous precipitation कौन सा cloud? Nimbostratus. Very correct. It is nimbostratus that gives continuous precipitation, usually associated with temperate cyclones. Okay. You see how many PYQs I'm going through for this particular chapter? You know the importance of climatology, right now? No, no. Practice. Take 5 minute break, meaning you can do your thing within the classroom. You're not allowed to leave. Okay, people, the break is over. Here we go. The next indicator that we are looking, girls, mind, boys at the back over there. Okay. The next indicator of weather that we are looking at is pressure. Okay. So in this, we are going to try to understand what atmospheric pressure is. We'll look at the various scales of it and all. We'll try to understand what is the difference between vertical and horizontal variation of pressure. We'll look at the various factors that affect the wind velocity and direction. Okay, so here we are going to study Coriolis force, frictional force, pressure gradient force, gravitational force, and then obviously a theoretical wind called as geostrophic wind. Okay, and then this general atmospheric circulation. We've done this since school days, so it should not be so difficult. We look at planetary winds. We look at the various pressure belts formed and within which belts these planetary winds blow. Okay, we are going to look at those. So different pressure belts and planetary winds that go with it. And then lastly, there is a thing called as jet streams. We are going to look at those and the various types of jet streams because that is a question, a definite question in the UPSC exams. And lastly, the shifting of pressure belts. Okay. Uske baad, after that pressure belts and thing is done, we'll look at local winds. This is where you will source a lot of your questions in climatology. Okay. So this is the place where they keep asking you which is a cold wind, which is a warm wind, which wind blows in which region, and so on and so forth. Okay. So these are those various winds that we are looking at. Local winds, and at the very end we are looking at weather systems, that is cyclones and anticyclones. Okay, okay, cool. I'm not planning to do everything today, but I'll at least try to look at the first two topics. Okay, first of all, atmospheric pressure. You feel a certain pressure on you, right? Clearly. Now the thing is, girls and boys, anybody talking, I'm going to ask them to leave the classroom now. Okay, it doesn't matter if there are 5 minutes left or 10 minutes left. I'm still going to ask you to leave. Atmospheric pressure is the weight of the air column, okay, that is situated above you. You know there is atmosphere above the ground surface, right? So that air column from the mean sea level to the top of the atmosphere, whatever pressure it exerts on you is called as atmospheric pressure, okay? We term that as, it is measured in millibars, bars, pascal, kilopascal, or pounds per square inch, okay, PSI. You've been through all of these units in school. So at sea level, one atmospheric, and remember this table, yeah? This is the thing that you've got to remember. At sea level, one atmospheric pressure measures some 1013.2 millibars, okay, or 1.03013 bars, or then 101325 pascal, or 760 mm of Hg, meaning 760 mm of mercury, or 34 feet of water, or 14.7 psi. Okay, this is the unit for one atmospheric pressure, and you've got to remember this. UPSC tends to ask you these things because this is properly printed in your NCERT books. So you got to remember this part. Okay, okay. Now let's understand the vertical and horizontal variation of pressure. The vertical pressure, first of all, let's look at that. You're saying that pressure decreases. You know that as and how you go above the surface of the surface of the ground, you will feel that the pressure becomes lesser and lesser, right? You will feel that the air also becomes a little rarer. You know, air bhi thoda sa rare lagta hai. So clearly on mountains and all, if you climb mountains, there is one reason. You remember they always tell you when you go to Leh Ladakh, they'll always tell you to acclimatize first. That don't go and start doing your activities immediately. Stay over there for a couple of days and acclimatize yourself. You understand what you mean to acclimatize yourself? You get acquainted, you get used to the climate there is. Okay. So if because the pressure is pretty low, you need to get used to that because your blood pressure, why does the air pressure matter to you? It is the one that is opposing you with the blood pressure that is flowing in your veins, right? In your arteries and veins, in your blood vessels. Now you're saying if that changes a little, then clearly one side of the pressure is going to be a little less and the other side of the pressure is going to be a little low, and that is going to affect your body. Okay, remember those things, when the things that happen when the air pressure in airplane cabins are not correctly maintained, and then people bleed through their ears or nose or something like that. That is because the vessels bleed, the blood vessels burst and bleed. Okay, hence that how do you say, blood flow that you can see. Okay, okay. So we are saying that that pressure needs to be adjusted. So now this pressure will keep on decreasing as and how you go above. Okay, above the ground level. And that rate of decrease is 1 MB per 10 meters or 100 MB per kilometer. Okay, and that is a huge amount of pressure difference. That's a great pressure gradient. Okay, 100 MB per kilometer is a huge amount of pressure gradient. You are saying the vertical pressure gradient force is much larger than the horizontal one. Okay, like when air flows on the ground, then that flows because of the horizontal pressure gradient. Okay, so we are saying that horizontal pressure gradient is quite less as compared to the vertical one, meaning the air is this is high pressure. On the ground, it is going to be high pressure, but as and how you go upwards is going to be low pressure. Okay, so ideally, which way should the winds work? Like this. Huh? If this is high pressure and this is a little low pressure, then ideally the winds should be working in an upward direction, right? There should be a proper vertical upwind होना चाहिए था. होना चाहिए कि नहीं होना चाहिए? होना चाहिए. But do you feel that? Do you ever feel like the air is going upwards? No. Why? Because of the gravity. Okay, the gravity is almost equal and opposite to that, so that keeps balanced and you don't feel that pressure. Okay, you don't feel that vertical upwind at all right. Okay, now let's look at the horizontal pressure. Okay, the horizontal variation of pressure is going to be because there is a high pressure region someplace, there is a low pressure region someplace. Obviously winds are going to, because there is a pressure gradient, obviously wind is going to flow from the high pressure region to the low pressure region. Okay, can pressure depend upon temperature? Yeah, pressure can depend upon temperature, right? Yeah, so clearly we are saying that the pressure depends on temperature, and clearly that temperature and pressure together are going to cause the direction of the wind. Okay, they are going to decide the direction of the wind. So wind will always blow from a high pressure region to a low pressure region. Okay, let's look at it like this. Let's say this is the high pressure region, and let's say this is the low pressure region. Okay, so ideally wind should be blowing in this direction from a high pressure region to a low pressure region. Okay, now you know that there is a pressure gradient over here. Okay, you have no clue how much the pressure gradient is. If I say the pressure gradient is a little more, okay, if I say this is some 1000 MB, okay, and this is some 980 MB, okay, so clearly now the pressure gradient is 20 MB, okay, so now the wind is going to flow faster, okay, because the pressure gradient is a little more, okay, instead of 980, if I say the pressure gradient is 990, okay, so now is the pressure gradient more or less? The pressure gradient is lesser. Okay. What will happen to the wind? It will blow a little less faster. Okay. The velocity will be a little less. Okay. Do you understand? The greater the pressure gradient, the faster the velocity of the wind. Okay. The stronger the stronger the current of the wind. Okay. Now there is also something called as isobars. Remember when we had studied temperature, we had checked out isotherms, right? What were isotherms? We said that those are all lines joining places of equal temperature. Agreed. So isobars will be all those imaginary lines joining places of equal pressure. Okay. When the place has equal pressure, when different places have equal pressure, if you join them in a line, that will be called as an isobar. Since pressure and temperature are interrelated, ideally we say that isobars should be perpendicular to the latitudes, sorry, parallel to the latitudes, okay? Because temperature and pressure change with the latitudes, right? So we are saying that ideally they should be parallel to the latitudes. Once again, you have the same problem that you have with temperature, that the northern hemisphere is very, very distorted in the sense, in the way the land and water is distributed, okay? This is the northern hemisphere. Okay, we are looking at the northern hemisphere above and the southern hemisphere below. Okay, so now your concern is that the northern hemisphere has a lot of land. And what is the property of land? It will heat very quickly, it will cool very quickly. Okay, but it will heat up very fast, very quickly, and it will cool down also just as quicker. Okay, so now unfortunately what happens is, instead of being parallel lines over here for isobars and isotherms, what you will get is localized circular loops, okay, of isobars and isotherms, okay, because of continentality. Because of the factor of continentality, what you see here is circular loops of isobars and isotherms, okay, okay? Because as and how you go inwards in a land, the temperature either will keep rising and rising during summer or falling and falling during winter. So the same with isotherms, the same thing with isobars. So isobars will be pretty regular and parallel to the latitudes in the southern hemisphere because there is more water, less amount of land. But in the northern hemisphere, it is going to be a little distorted. Okay, distorted circular loops will जाएंगे आपको. Is this good? Huh? Okay. Okay. Clearly, if the pressure is going to change rapidly, if the pressure gradient is more, isobars will be close, right? Huh? They will be closely spaced. And if the isobars are far away, then clearly the pressure gradient is not much and the winds will flow a little slowly. Okay, they will not flow as rapidly. Is this good? Huh? Clear so far? Okay. Lastly, you go to these factors, okay? The factors affecting wind velocity and direction. Let's consider the very first force. We are looking at the pressure gradient force. What is the pressure gradient force? We say pressure gradient force is the force that will be caused due to the difference between the atmospheric pressure of places. Okay, there is a place which has high pressure, the other place has a low pressure. So winds will blow from a high pressure region to a low pressure region. Okay, and that is the pressure gradient force. If the isobars are close to each other, clearly the wind velocity will also be higher and the pressure gradient is more. If the isobars are spaced far away from each other, then clearly the pressure gradient is less and the wind will flow with a lesser speed. Okay, ठीक है, agreed? And ये जो Coriolis force होता है ना, that is always perpendicular to the pressure gradient force. Okay, that you need to remember. Okay, so moving on to the Coriolis force now. We are trying to understand what the Coriolis force is. Okay, we are saying that the Coriolis force is the force exerted by the rotation of the Earth. This is the equator. This is the Earth. This is the equator. Okay. I had explained to you, not you guys, some other class, that what happens is the Earth rotates. Okay, and the Earth is going to rotate fully, completely. The Earth is going to rotate for within 24 hours is going to complete a rotation of 360 degrees. Okay. Now the thing is, it is far bulkier in the center, right? At the center, at the equator, the Earth is a little, the radius is clearly a little more, and at the poles, it is clearly a little less. Okay, fine. So obviously, the equator has to go at a faster linear speed to finish that same rotation within 24 hours. The equator is going to be a bit faster, but the rest of these latitudes are going to be a bit slower. Okay, agreed? So you are saying that the equator is at a much faster speed, but as in how you go from the equator towards the poles, every latitude is going to have a little lesser speed than the equator. Okay. For example, if this latitude, say suppose this latitude is 30 degrees north. Okay. So 30 degrees north is going to be is going to rotate at a lesser speed than the equator. Agreed? Okay. 60 degrees north is going to rotate at an even lesser speed than 30 degrees. Agreed? Agreed. And then finally 90 degrees is going to be almost zero. Okay, 90 degrees latitude at the poles, the linear speed of rotation is almost zero. I'm not talking about the angular speed of rotation. The angular speed of rotation will remain constant for the whole of Earth because every single point of Earth is going to complete its rotation within 24 hours, right? Agreed? But we are talking about the linear speed of rotation. We are saying that this linear speed, not rotation, linear speed is going to be lesser with every latitude as in how you move from the equator towards the poles. Okay? So clearly there is a difference in speed at various latitudes. Now let's say there is an object which is supposed to travel from point A to point B. Okay, say this is point A and this is point B. The object is supposed to travel from these places. Okay, clearly the equator is at a faster speed. Okay, the 30 degrees latitude is at a lesser speed. Okay, ideally कहाँ जाना चाहिए था? It should have landed at point B. If you're going straight through, it should have landed at point B. The 30 degrees latitude is moving at a slower speed. Okay, so by the time it should have reached this point B, it has actually only reached point B1. Okay, so this motion happens to be over here. This is where the object will land at 30 degrees 30 degrees north. Okay, why? Because that particular latitude is moving at a slower speed. Okay, that is why there will be a slight right deflection to the right in the northern hemisphere and a slight deflection to the left in the southern hemisphere. Okay, that is the Coriolis effect. We cannot necessarily call it a Coriolis force, but we need to call it the Coriolis effect. Okay, the slight deflection of freely flowing objects which are moving across latitudes. There will be a slight deflection towards the north in the northern hemisphere, to the right in the northern hemisphere, and to the left in the southern hemisphere. Is this correct? Huh? Okay. So we are saying this is what the Coriolis effect is about. We say that it deflects the wind to the right in the northern and to the left in the southern hemisphere. जितना ज़्यादा velocity ज़्यादा होगा, the more the velocity, the deflection will be greater. Okay, fine, agreed. If the winds are moving at a faster speed, then clearly the deflection will also be a little bigger. Okay, and it will be proportional to the latitude and the pressure gradient force. So clearly, if this is moving over here, the deflection will be a little lesser. If this is traveling over here, the deflection will be even more. Okay, why? Because the difference between speeds is greater. So the deflection will also be greater. Okay, agreed. So you have to remember the Coriolis force is the Coriolis effect is zero at the equator and it will be maximum at the poles. Okay, the Coriolis effect is essentially, or the Coriolis force is essentially the difference between speeds. At the equator, there is zero difference between speeds, right? Because the maximum speed is also at the equator and the speed that you're comparing is also at the equator, right? So there is zero difference between speeds. But over here, the speed is maximum. Over here, the speed is zero. So where will the Coriolis effect be greatest? At the poles, because the difference is the greatest at the poles. Okay? Okay? Why am I feeling I've lost you guys now? No, you're with me. You're with me. Hey, सब समझ रहा है? थोड़ा थोड़ा समझ रहा है. Okay, ठीक है. No problem. Yes. हाँ, लेकिन बहुत ज्यादा deviation होगा अगर आप उसको course correction ना करो. I'll tell you how this works is ना usually in practical life. इसीलिए I said this cannot be compared to a cricket match. Like you're throwing a ball between 22 yards is not much of a difference, right? You're not talking of that difference, or you're not talking of a baseball match where you're throwing balls or footballs. You're not talking of Coriolis force will not create a difference over there over such small spaces. You want to travel across latitudes for this to happen. And where do you usually travel across latitudes? Winds, you know, planetary winds travel across latitudes, ocean currents travel across latitudes. If you're talking of human beings, moving around things, then you're talking of airplanes or ships, cruise lines, and stuff like that, right? Those travel across latitudes. And all of these usually have a course correction within themselves. It is inherent to the system. It is inherent to the guiding system that you have a course correction for Coriolis effect. Okay, because you know that if you let it go by itself, it is going to land a little towards the right. It will not take you to that destination, the destination that you had promised or thought of earlier. It is always going to go a little to the right in the northern hemisphere and a little to the left in the southern hemisphere. What is affected? Airplanes traveling across latitudes will be affected by Coriolis effect. It is not just the Coriolis effect, they will be affected by the jet streams also, by the geostrophic winds also. So that is going to be a huge thing. When we look at this jet streams, I'll explain to you how that works. There is a World War II story also about it. Okay, people, do you understand Coriolis effect? Okay, moving on to gravitational force. We already discovered that there is always going to be a vertical upwind होना चाहिए था. Ideally, there should have been an upwind because there is a huge pressure gradient between the pressure at the ground surface and the pressure above. Okay, but that does not happen because of the gravitational force. So the gravitational force will always act in a downward direction. That is also affecting the wind velocity and direction. Lastly, you have the frictional force. Okay, frictional force will be more important, say around 1 to 3 kilometers from the surface of the earth. Okay, because you're going to meet most obstructions over here. What is friction? That the wind is going to collide against objects or obstructions along the surface of the earth. Okay, that is going to essentially be that is essentially going to be the frictional force. That is going to be the cause of friction, right? So if you move to the upper atmosphere, if you move some 3 kilometers above, how many frictional forces are you going to meet? How many obstructions are you going to meet for that frictional force to exist, right? So clearly that frictional force will be minimal at that point, because clearly 1 to 3 kilometers above the surface of the ground, you're not going to find a lot of obstructions, so the friction force will not matter much. Okay, and usually at the sea surface, because there is less, if wind comes and touches the sea water, what kind of friction can it generate? The sea surface is very, how do you say, flexible, right? So no friction there. It is not pushing back at the wind, is it? No, it is not pushing back at the wind. It is not solid to push back against the wind. So clearly the frictional force will be minimal at the sea level. Okay, ठीक है? एक geostrophic wind का concept explain करते हैं, then I'll stop here. Geostrophic wind ना क्या होता है? It's a theoretical kind of wind जो upper surface में होता है. Okay, in the upper atmosphere you find that usually 1 kilometer above the ground surface. You're looking at 1 kilometer above the ground surface. What you're essentially doing is they're saying essentially that the gravitational force, the Coriolis force, the pressure gradient force, and the frictional force act on the wind, right? These are the 4 forces that are acting on the wind. So you are eliminating the frictional force completely. You say, well, frictional force, we are going to take it off from the equation, take it away from the equation. Now what you are left behind is with just the gravitational force, which is usually acting in a downward direction, and 2 major forces, the Coriolis and the pressure gradient force. Okay, ideally Coriolis and pressure gradient force should act in a perpendicular direction to each other. Okay, the pressure, how is the pressure gradient force act? Wait a minute, I have a figure for it. This is what we are looking at. Okay, see, this 1000 MB is going to be low pressure, 1008 MB is going to be high pressure. Agreed? This is going to be a high pressure region, that H shown by H, indicated by an H, and this is going to be the low pressure region indicated by a L. Okay, so ideally, where does your pressure gradient force make the wind travel? What is the direction? From in this direction, from high pressure region to low pressure region. Okay, the red line, this red arrow indicates that. That is the pressure gradient force, because it is the difference between the pressure that is making the wind flow in that direction. Agreed? ठीक है? Where should and the Coriolis force should ideally act in the right ways, right? Because this is the, okay, I see, if this is the way the wind works, then how should the Coriolis force act? In this direction, right? Agreed? So it is ideally working in this is the direction of the Coriolis force, perpendicular to the pressure gradient force. Okay, that is the pressure. The Coriolis force should always act perpendicular to the pressure gradient force. Okay. Now what we are saying is that since we have eliminated this completely, frictional force completely, we are saying this is a special condition in which the pressure gradient force is exactly equal and opposite. This is the pressure gradient force. We are saying the pressure gradient force is exactly equal and opposite to that of the Coriolis force. Okay. And because of that, the resultant wind is going to move in this direction. And how is it moving? It is moving parallel to the isobars. Okay, this wind is moving parallel to the isobars. Normally, how should wind move? If these are the isobars, the wind should move perpendicular to the isobars. You know, normally on ground, how does the wind move? It moves perpendicular to the isobars. How is this geostrophic wind moving? It is moving parallel to the isobars. So this is a special condition. Okay, this is a special case. It is called as geostrophic winds. Geostrophic winds के practical applications are going to be once again, wind, airplanes. Okay, so when the airplanes are flying, you try to either avoid the geostrophic wind or you try to fly with it depending on what is the direction of your wind. Okay, the direction of your flight. So if you are moving, you try to save on, this, what do you call? Fuel. You try to save on the fuel. You try to not be in its way. Okay, if the geostrophic wind is moving in this direction and you're moving in this direction, you either fly above or below it. Okay, to avoid that entire wind. Okay, that is the general idea. Same with jet streams, but also with geostrophic winds. Okay, clear? Okay, thank you very much for your attendance.